homework time, and oh, I gotta be straight with y'all. This homework is kind of long. I mean, it's only 13 questions, but it runs on for 4 pages. But we'll groove through it, okay? I just gotta be straight with you. Let's start. Let's do it right, though. It's worth doing. Let's do it right, because you're gonna learn a lot from it, and that's why we're doing it. Not just to make you suffer, as much fun as that is. So go ahead, jot your name down at the top. I'll put my name, you put yours, and take a moment to write in today's date. I'll write today, you write the date, where, and when you are. Now, number 1, we have a pool, a rectangular pool. It is 7 feet wide. It is 3 times as long as it is wide. So let's label the diagram with the dimensions of the pool. So here we are. We have 7 feet is our width here. So let's label that. And I'll use the abbreviation for feet. And then the 3 times long, well, that means 3 times 7 feet, right? So this section is 7 feet. This section is also 7 feet. And this section is also 7 feet. And so you could multiply these to find how long the whole pool is. And 7 times 3? Okay, so that's 21 feet. See, I said there's a lot to do, but look, we're already done with 1A. That's it. Label the diagram with the dimensions of the pool. Done. And now to find the perimeter, well, that's pretty easy. I'm going to do my math up here where I have a little more room. So I know that perimeter, let's remind ourselves, perimeter is 2 times the length plus the width. Okay. So that means in this case, the perimeter is going to be 2 times what? Well, what are our length and width? All right, so we have 7 and we have 21, right? Okay, so 7 plus 21. And I'm not going to go into the wherefores and whys of that. You can go back to lesson 1 if any of this is confusing you. We're going to plug on here, assuming you understand perimeter in the formula for it. So then 7 and 21 make what? So our perimeter will be 2 times, right? 7 plus 21 is 28. And now to do this, we can do this multiplication logically. Instead of by cold calculation, we can say, hey, 2 times 20, break it out into the units, 2 times 20, that's 40. 2 times 8 is 16. 16 and 40. Can you add 16 and 40 in your head? You can even break that down into the 16 into 10 and 6. Add 40 and 10 is 50. Another 6 is 56. There we go. Now we're talking about perimeter. We're talking about walking around the edge of this pool. Very carefully so you don't slip and fall and crack your head. Walking all the way around, it's 56 feet in this case. We're labeled with 56 feet. Okay, so look at that. I mean, say, yeah, not so bad. Hey, we already did number 1. Let's move on to number 2. All right, and you'll see, actually, that this isn't so rough, right? Because now instead of a pool, we have a poster. And instead of feet, we're talking about inches. It's the same idea, except that here we draw the diagram. They're not giving it to us. So a poster is 3 inches long. It is 4 times as wide as it is long. Well, I'm not going to be a stickler about what we call length and width. So if you want to be, go for it. I'm just going to draw this one kind of like the pool one, just to make life easy for me. You can do whatever you want. So I'm going to start, though. I'm going to draw a square instead of drawing the whole poster. And let me show you why. I'm going to call this 3 inches long here. And then it's 4 times as wide as it is long. So there's one set of 3 inches. Now you see what I'm doing. There's a second set of 3 inches and a third set of 3 inches, and a fourth set of 3 inches. You see why I did it this way? Now you could have just drawn the rectangle and then split it into parts, but I think this makes it easier to see why we're doing this. Alright, so now the whole thing here is 3, 6, 9, 12, or I could do 3 times 4 is 12, of course, and we are talking about inches. And that makes sense, right? 3 times 4 is 12, is 4 times as wide as it is long. Okay, so now in part B, we just simply find the perimeter and the area. And we know how to do this. Remember, perimeter is 2 times the length plus the width. So then our perimeter will be 2 times what? What are the length and width? 3 and 12. And again, I am not a stickler about what we're calling length and width here. If you want to be, go for it. I got better things to do. Because it's commutative. Yeah? All right. So anyway, it does matter, just not to me. Huh. Okay, so 3 plus 12 is what? 15. All right, great. And now can you tell me what the perimeter is? 2 times 15? You know that? You could do it as 2 times 10 plus 2 times 5. So 20 and 10 make 30. Good. And now we're talking about walking around the edge of the poster, as strange as that is. We're walking around the edges of the poster, the outer linear measurements. We're just talking about straight inches. All right, and now for the area, we know that's the length times the width. Find how many square inches, in this case, are inside the area of the poster. And so what are the length and width? Well, we know that they are 3 inches and 12 inches. So, and what is 3 times 12? Well, again, you can break this down into 3 times 10 is 30, plus 3 times 2 is 6, 30, and 6, 36. Unless you happen to just know that. That would be great. And now we're talking about the space. How many little squares that are 1 inch by 1 inch inside the poster? So squarea, area. So we're talking about square inches. And I'll put it with the abbreviation square inches. Excellent. Look at that. You're done with number 2 already. Hey, not so bad after all, eh? All right, let's go on. And in number 3, I think we can handle this no problem. The area of a rectangle is 36 square centimeters, and its length is 9 centimeters. So our question is, what is the width of the rectangle? Hey, no problem. Let's actually draw this bad boy out here. So we have 9 centimeters on this side, right? Now we don't really know how to draw the width. Is it shorter? Is it longer? We don't really know yet, okay? But I'm gonna just, well, I'm just gonna tell you it's shorter. So let's just draw it like this, okay? So that we can draw it. Now, if you drew it wrong, if you drew it longer that way, then that's okay. It works. So our area, we're told, is 36. So I'm going to write that inside here. 36 square centimeters, because that's the area inside it. And what we're trying to find here is the width, so I'll put W for that. Now we know that area is the length times the width. We are given the area in this case. We're given the area as 36 square centimeters, and we are given the length as 9 centimeters, and we're trying to find the width. Now there are a couple ways to go about this. I like just thinking, because you can look at this, and if you know your basic multiplication facts, and for the love of corn, I hope you do, you can look at this and say, well, 9 times what is 36? Okay, and let's say you don't know that. Could you skip count by 9s? 9, 18, 27, 36. Could you go grab a multiplication table and look down the 9 column and find 36. Now, that works because we're dealing with simple whole numbers here. So this would tell us then, what is our width? That's right. It is 4. The width is 4 centimeters. Okay, that was it. That's all I'd asked there. Now in the second one here, Elsa, I don't know where she came from, but Elsa's here all of a sudden. She wasn't in part A, but now Elsa's on the scene. She wants to draw a second rectangle. That is the same length, but is 3 times as wide. So we will draw and label this second rectangle. Now, here we do have to pay attention to length and width. Its length is 9 centimeters. So the length, I'm just going to make a little notation here. The length is 9 centimeters, and it's 3 times as wide. Well, what was the width? It was 4 centimeters. And the phrasing there might be a little confusing. Do we mean 3 times as wide as 9 centimeters or 3 times as wide as 4 centimeters? But it's saying is 3 times as wide as this one, which was 4 centimeters wide. Okay, so it's going to be the same length, Elsa's. So here we go. We'll draw the length of 9 centimeters. And I'm going to do it the way I did it up top, where I say, okay, well, that's 4 centimeters. Ooh, that's a horrible 4, sorry. That's a little better. Okay, maybe it's worse. All right, anyway, so, and then there's another 4 and another 4. So 3 times as wide. 1, 2, 3. So 4 centimeters and 4 centimeters. And I don't really have room for a bracket here, but I'm going to squeeze one in anyway. 4 and 4 and 4. 4 times 3. Yes, indeed, is 12 centimeters. So there we go. That's all we had to do there is draw and label it. And then part C will do something with this. All right, so let's go on to 3C. All right, in part C we're asked what is the perimeter of Elsa's second rectangle. And we'll just draw it quickly down here. We don't have to make it too schmancy. Just we know that it is a rectangle as such and that it is 9 centimeters by 12 centimeters. We don't have to do all the configurating again. So just the perimeter is the distance around it. So we know that perimeter is twice the length plus the width. So in this case, the perimeter would be 2 times 9 plus 12, right? Those are our dimensions here. So the perimeter would be 2 times what? 9 plus 12 is 21. Blackjack. All right. So what is 2 times 21? Well, you can do 2 times 20 is 40. 2 times 1 is 2. 42. 42. And we're talking about perimeter, so we're securing the perimeter. We're walking around Elsa's second rectangle. And how far did we walk? We walked 42 centimeters. There's no square here. We're not talking about the area, the space inside. Just walking the line, securing the perimeter. 42 centimeters. That's it. Look, you're done with 3. We're really blowing through this. Nice. Let's go on to 4. All right. You see, 4 goes on for a little bit, so let's kind of slow down, take our time here, do this right. The area of Nathan's bedroom rug is 15 square feet. The longer side measures 5 feet. His living room rug, so now we're talking about a different rug, is twice as long and twice as wide as the bedroom rug. Okay, so first we're going to draw and label a diagram of Nathan's bedroom rug and answer the question, what is its perimeter? So we're not even going to think about the living room rug at first. Okay, so let's just draw and measure. We know its area. We know the longer side. So let's draw that longer side, which we know is 5 feet. And then we have a shorter side, presumably, right? Okay, great. And we know our inside space here, we're told, is 15 square feet. That's the area in squarea feet. All right. So now if we were to think about this, before we can calculate the perimeter, we need to find the length over here, right? So what's the length? Well, we know that area is the length times the width. And so we do have one side. All right, so let's say the area is the length times 5. And we know the area is 15 square feet. So that would be the length times 5. So what times 5 is 15? And yes, you could put this as 15 divided by 5 will give you that length. So what is that magic number? What times 5 is 15? That's right, it is 3. And so our length is 3, and we're talking about feet. However, we only had to solve for that length in order to discover the perimeter. So right here, this is, I'm just going to put a little equals 3 feet here, so I remember that. So our perimeter then of his bedroom rug, we're still on here, is going to be 2 times the length plus the width. All right. So the perimeter will be 2 times what? What's the length and width? You got it. 3 and 5. Our length and width. So that would be, perimeter will be 2 times 3 plus 5 is 8. And so our perimeter is 16. Great. 2 times 8 is 16. And we're walking around. We're securing the perimeter of Nathan's bedroom rug to keep it safe from invaders. So we're walking around that line. So we're just talking about feet. We're not talking about the area. We already have that. The perimeter is 16 feet. Now, with our living room rug, it's going to be twice as long and twice as wide. So this is easy to draw, right? All right, so I'm just going to draw something. I'm not going to make this overly complicated, huh? All right, so look, if this is the original rug, right? It's 3 feet here, and so it's twice as long, so that's another 3 feet. So how long is the living room rug? You got it. 3 feet and 3 feet are 6 feet. And if it is twice as wide, well, okay, look, up to here, it's the bedroom rug, right? So it's 5 feet, that was, and then another 5 feet, because it's twice as wide. And so how wide is it all together? You got it, 10 feet. And if you notice, I just want to point this out because it'll be relevant in a moment. It's almost like we took his bedroom rug, like if we had 4 of his bedroom rugs and stitched them together to make the living room rug. Do you see that? Here's a 3 by 5 bedroom rug, right? Here's another 3 by 5 bedroom rug, or red room bug, whatever you want to call it. Here's another one, and here's another one. 1, 2, 3, 4. So I just want to point that out. So now we're going to find the perimeter, though. So we know our perimeter is 2 times the length plus the width, which in this case is 2 times what? Well, our length, or total length, is 6 feet, and our width is 10 feet, because we're double. So our perimeter is 2 times what? 6 plus 10 is 16, of course. And so then our perimeter, what is 2 times 16? A couple ways you can do this. You could break it down in units. 2 times 10 is 20. Remember that, 20. 2 times 6 is 12. 20 and 12, 32. And again, we're securing the perimeter. We're walking the line around it. So we're just talking about feet here. And look at that. So we did A and B. Let's go and do the other parts of question 4. Hey, this isn't so bad after all. Oh, good. Okay, as you can see here for part C, I made a quick sketch already so that you can remember. You can see it on your paper, so you don't have to do this sketch unless you're just cool like me. So it's asking, what is the relationship between the 2 perimeters? Well, the bedroom rug perimeter was 16 feet. And so then when we doubled the length and doubled the width, we doubled the perimeter. So that is what we just looked at. See, 16 times 2 is 32. All these numbers are doubled. 3 feet, 6 feet, 5 feet, 10 feet, 16 feet, 32 feet. They're all doubled. So we can say the relationship, there are many ways to put this, but one way to explain it is that when we doubled, and it's important that we specify both the length and width. When we did that, what did we do? We doubled the perimeter. All right, so we see that there is a direct relationship between length and width and perimeter, as you'd probably expect. And so now we're asked to, in part D, find the area of the living room rug, which is the larger one here, using the formula A is length times width. Well, I won't have to write it again this time because it's there. So I can just say the area is the length times the width, which for the living room rug is 6 by 10. 6 times 10. And we are talking about feet here. So what is the area? What's 6 times 10? 60. Gosh, that couldn't have been easier, huh? But what are we talking about? What's our units? Area, squarea, right? We're talking about how many square feet are in here. And you can look at that picture and kind of imagine that there are 10 square feet going across. And there are 6 rows of those, 10, 20, 30, 40, 50, 60. So you can keep in mind, we're talking about area, we're talking about square feet. And I'll use the abbreviation. And obviously, I'm emphasizing this because this is the most common error with dealing with perimeter and area in 4th grade is confusing the two. So every time, think perimeter is securing the perimeter, walking around. Area is that whole space inside. Like if you were going to paint it, that's the area. If you were going to lay down tiles, that's the area that it takes up. Whereas the perimeter is that distance around. All right, well, we have actually, on question 4 here, we actually have a part E and F. So let's go on to EF. Now, in parts E and F, I've again reproduced the basic drawings from up above with the area and perimeters, length and width notated. You have that right on your sheet, so you don't need to draw these out, unless, of course, you are cool like me. So the living room rug, which is the larger one here, has an area that is how many times that of the bedroom rug? Okay, well, look at the area of the living room rug. Here it is, 60 square feet. And then the area of the bedroom rug was 15 square feet. And let's just make sure we understand why. If I were to, remember we did this when we first drew these, how, making dotted lines here so you can see. So if I were to take his little bedroom rug, I could put one here, and one here, and one here, and one here, and it would match up. So it would take 4 of these little bedroom rugs to make one larger living room rug. Like I said, you could stitch 4 of these together to create a living room rug. So the area, 15 compared to 60. The area is how many times larger? Yes, it is 4. You see how we have 4 of these smaller rugs within the larger rug? And that might be striking you as strange because you say, well, we doubled it. We only doubled it. We didn't quadruple it. But we doubled both the length and width. If we had only doubled the 3-foot length to 6, well then, and kept this as 5, well then, yeah, we would have just doubled one of them. It would have been like 2 of those. But we doubled both the length and the width. That's why it's like, well, double here is quadruple. So the living room rug, in our actual response here, the living room Eureka Math the musical, and we'll do apostrophe S. The living room rug's area is 4 times and instead of saying that of, I'll say the area of, just to be totally clear, the bedroom rug. And most important, though, is not just to write that answer, but to understand why, because we doubled both the length and the width, so it's like having 4 of these smaller rugs. And now we're going to compare how the perimeter changed with how the area changed. Explain what you notice using words, pictures, or numbers. Well, we already noted in the previous part here that the perimeter doubled, whereas the area quadrupled, right? Okay, so what do we notice? So first, let's just make that comparison, like we just noted, that the perimeter doubled comma, while the area, and we'll use our big words there, quadrupled. So quadrupled. Okay, and so now how would we explain this using words, pictures, or numbers? Well, believe it or not, that picture up here, which if you was cool like me, you actually drew, this picture can be used to explain here for part F. So if I were to take this, I could draw some arrows here that this is times 2. And so, now this is going to be a tricky one to draw. I guess I'll go the long way around. The 5 is times 2. But the area here, I'm just going to use this A here, Captain America, area rather. See how there are 1, 2, 3, 4. The area is 4 times. So adding the arrows onto this drawing uses a picture to demonstrate that and numbers as well, to demonstrate that the perimeter is doubled because the length and width are times 2, whereas the area is 4 times. If you wanted to do this out, you would just simply say that, the 16 times 2 equals 32, whereas 15 times 4 equals 60. That would do it in numbers. To explain it in words, you would basically explain what we explained, that when you double the length and the width, you've doubled the perimeter, but quadrupled the area because you've doubled both the length and the width, and 2 times 2 is 4. All right, well, different ways of explaining. I'm primarily relying on my picture there to demonstrate that I have 4 equivalents of the area of the smaller rug within the larger rug, whereas I've just doubled the length and width. All right, well, believe it or not, you are done. Homework time is over, so I will see you next time. It is, again, homework time.